Hello everyone. In this presentation, I will concentrate on the topic of 4 transistor dynamic as well as 6 transistor static CMOS memory cells. So we have already discussed what is meant by a dynamic memory cell as well as static memory cell. So in case of dynamic memory cell, we have dealt with the concept of 1 transistor dynamic memory, 3 transistor dynamic memory cell, and in case of static memory cell, we have dealt with the concept of pseudo CMOS static memory cell, wherein I had discussed the concept of refresh operation. So in case of dynamic memory cell, you are going to perform the periodic refresh operation, whereas in case of pseudo static CMOS, we have considered one more additional transistor applied with the clock signal of phi 2, which is going to perform the refresh operation by itself when you are going to finish off with the write operation. So now let us discuss the concept of both dynamic as well as the static memory cell in terms of 4 transistor as well as 6 transistor. So if you look into this particular circuit diagram, this is the representation in combination with the 4 transistor DRAM as well as 6 transistor SRAM. But in exam, there are 3 different ways of asking question according to this particular concept. First thing is they may ask you to describe the working of 4 transistor dynamic memory cell. So if only 4 transistor dynamic memory cell is asked, you are supposed to draw this first circuit as well as the third circuit. So I will just mark over here, this is first circuit, this is second circuit, and this one is third circuit. So in exam, if they ask you only 4 transistor DRAM cell, then draw the circuit 1 as well as circuit 3. So this one as well as this one whole. So in completion of till IO bus complement. So if they ask you to explain only the 6 transistor static memory cell, then draw the circuit 2 as well as circuit 3. If they ask you to explain both, then you are supposed to draw all the 3 distinct circuits. So this is how you are going to look into the question carefully. Depending upon the question, you are going to change your circuit diagram. So coming to the concept of 4 transistor now. So why it is called as 4 transistor? This transistor T1, T2, T3, T4 are responsible to perform the memory operation in case of a 4 transistor dynamic memory cell. So for that purpose, it is called or designated as 4 transistor type of dynamic memory cell. This is called as 6 transistor type of static memory cell, because here we have 2 NMOS transistor, that is T5 and T6, 2 back-to-back connected inverters you can see. So one inverter is comprising of 2 transistors if you replace it in the form of MOSFET. So 2 transistors plus 2 transistors for this inverter, 4 plus 2 transistors over here. So it is called as 6 transistor type of static memory cell. Apart from that, we are having the third circuit, which is going to behave just like a flip-flop. So I will come back to this concept once I start explaining you individually what is the 4 transistor as well as 6 transistor memory operation. So let us discuss first upon the concept of 4 transistor type. So it is called as 4 transistor type because of the presence of 4 transistors which are responsible for performing the memory operation. So first and foremost thing is, here you can see the horizontal line over here, which is represented in terms of recharge complement coincident with phi 1. So here phi 1 and phi 2 in this particular diagram represents the two phase clock signals. Phi 1 clock signal is going to precharge a particular transistor up to a level of VDD, or we call it as a logical 1 state. So precharge complement, which means that you are going to apply the precharge complement signal as equal to 0. So when this becomes equal to 0, obviously 0 means it is carried to this also. This will also be equal to a logical 0 state. So we already studied the concept for turning on a transistor of P MOSFET. The gate terminal should be applied with the logical 0 state. So when I am going to apply logical 0 state, transistor T6 will get turned on. Along with that, transistor T5 is also turned on. It will be behaving like a closed switch, so it will get precharged to a level of VDD. So both the cases, it will be precharged to a level of VDD because of the presence of the transistor T5 as well as transistor T6. By choosing an appropriate column select signal, say if I am asserting the column select signal as equal to 1 state, So this particular column select signal and this one. So whatever the clock signals you are going to choose. So for row select as well as for column select, you are going to have the different clock signal, that is clock signal phi 2. So when I am asserting clock signal phi 2 as equal to 1, it is going to be asserted with the column select as equal to 1. Also the row select signal becomes equal to 1 because both of them are coincident with the clock signal of phi 2. So when this becomes equal to 1 is applied to the gate terminal of the N MOSFET. So this particular transistor will get turned on and this transistor will also get turned on. So accordingly, whatever may be the charge which is stored in Bitn and Bitn complement. So you can see here it is having both the complemented as well as the normal form, that is in terms of both logical 1 state as well as logical 0 state. So when this is on, obviously this entire line will get activated. So I told you for 4 transistor type of dynamic memory cell, you are supposed to draw the first circuit as well as the third circuit. So it will be having a continued connection wherein the bit n as well as bit n complement signal, whatever the signals are stored in these particular lines, will get discharged through this particular transistor which is turned on, will get discharged through this transistor which is turned on in terms of input output bus as well as input output bus complement. So this is how you are going to have the initial stages which are going to be performed. So before starting with the operation, that is in terms of write operation as well as read operation, I wanted to tell you all these things. So next, coming to the individual operation. So first let me start with the write operation. So when I am performing the write operation, I am going to pre-charge this particular transistor, that is T5 as well as T6 will be pre-charged to a level of logical 1 state or VDD. Then I am going to have the column select signal asserted with logical 1 state. So it is coincident with the clock signal phi 2, whereas the pre-charge is coincident with the clock signal phi 1. Both should be mutually exclusive in nature. And the row select signal will also be asserted as equal to logical 1 state. Column select signal will also be asserted as equal to logical 1 state. So once you have this in terms of 1 state, both the transistors will get turned on. So how it will be discharged through the lines of buses, that is IO bus as well as IO bus complement, I have already told you. So now coming to the concept of this particular row select as equal to 1. So when column select becomes equal to 1, we have seen that these two transistors will turn on and it will discharge the level of logical states bit n as well as bit n complement through these buses. Now what happens when the row select signal becomes equal to 1? When row select signal becomes equal to 1, so this is 1 and this is also 1. So when this transistor is turned on, so transistor T3 is on, along with that transistor T4 is also on. So both are on means both will be behaving like an closed switch. So whatever may be the bit n signal constituted over here, that will be applied to the output terminal. So if 0 was present, it will be equal to 0 state. If 1 was present, it will be equal to 1 state. So since this transistor T4 is turned on, we have even asserted the column select signal as equal to 1. So whatever may be the bit n complement signal stored over here, it will be appearing towards the output of transistor T4. So here I will be getting bit n complement. So it depends upon the value. Your bit n value can take a value of logical 0 state or logical 1 state. Similarly, if this is 0, this will be 1. If bit n is 1, bit n complement will be equal to 0. So depending upon this value of BT, that is BITN, your BITN complement will be chosen. Suppose if I assume that the bit n signal was equal to 1, so obviously bit n complement signal would be equal to logical 0 state. So now if you see in this particular circuit diagram, here it is 1 whereas here it is 0. So this one, so 1 is for bit n bit n complement, if I assume it was equal to 0, 1 is carried to the gate terminal of transistor T2, whereas 0 is carried to the gate terminal of transistor T1. So 0 applied to the gate terminal of transistor T1 is an off state, whereas 1 applied to the gate terminal of transistor T2 is an on state. So transistor T2 will turn on, whereas transistor T1 will turn off. So if bit 1 or bit n was carrying a value of logical 1 state, then it would take a path something like this. So from here this transistor is on, from there the transistor T2 is on, then it is sent to the VSS. So whatever the logical state has to be stored, it will be stored in the gate capacitance Cg2 of transistor T2. So this is how it is going to perform the operation of write. Similarly, if this was equal to 1 and this was equal to 0, then obviously transistor T2 would have been turned off and transistor T1 would have been turned on. So whatever the value has been stored, that will be stored in the form of a charge in the gate capacitance of Cg1. So this Cg1 and Cg2 will be storing the charge during the operation of write. Once the write operation has been performed, we are supposed to do the read operation. So in case of read operation also, both these lines, that is bit n as well as bit n complement lines, it will be pre-charged to a level of logical 1 state or VDD. That is, I am going to assert a clock signal phi 1, wherein I will be applying the pre-charge complement signal as equal to 0. Transistor T5 and T6 will get turned on and it will be pre-charging the bit n as well as bit n complement to a level of VDD. So that will be done, and when you are having, say, if one has been stored, so if a one has been stored means your transistor T2 will be turned on, I told. So if bit n was carrying a value of logical 1 state, T2 will be turned on, T1 is off, and thus the bit line will be discharged to VSS through this particular transistor, that is transistor T2, and the stored bit will reappear in these bit lines. So that is how the read operation is performed. So whatever the charge is stored in this particular capacitance. So if one was stored in the bit line, that is this particular bit n value was equal to logical 1 state, means through the capacitor Cg2, since the transistor T2 is on, via transistor T3, that will be read through your bit line, that is bit n signal. Similarly, if this particular value was 0, bit n value was 0 and bit n complement was equal to 1, then that particular value will be read through the bit n complement signal through the charge which is stored in the capacitor Cg1. So from the capacitor to the bus, if you see, it is performing a read operation. From the bus, it may be a row select bus, it may be a bit line, or it may be a column select. If you are performing the operation in the form of storage of charge in the particular capacitor, it is nothing but a write operation. Reverse of that will be the read operation. So this is how the write as well as read operation will be performed in case of a 4 transistor dynamic memory cell. So when you are using such cells in the random access memory arrays, the area of each cell should be kept minimum and the transistor should be of a minimum possible size. So in case of a VLSI design system, we are mainly concentrating upon the low area. So in order to have the least area, you are going to choose the size of each and every individual transistor to be as minimum as possible. This makes them incapable of sinking large charges very quickly. So in order to avoid this, we are going to make use of the sense amplifier. So here you can see the sense amplifiers are used in this particular arrangement. So you can just recall the concept wherein I had told you for 4 transistors you will be using first as well as the third circuit. So till now I have not explained you about the third circuit. First circuit I have already explained in terms of read as well as write operation. So in case of third circuit we will be having a sense amplifier. So in which you are having the transistor C1, T1, T2, T3 as well as the transistor T4, which is going to form, if I consider only this much part, it is going to form a circuit of flip-flop. So if you are having this particular sense line, that is sense input what I have applied for the transistor T5 gate terminal, if I am making that as inactive state, or if I am making it as a logical 0 state, so obviously there is no need of usage of this sense amplifier at all, because when this becomes equal to 0, this transistor is turned off, so there is no connection from the flip-flop circuit to the sense amplifier. So what happens? The circuit will be only this much, which is going to have a connection with the bit n as well as the bit n complement signal. So whatever I am going to have, if in terms of sense line as equal to 0, then the state of the bit line is reflected in the charge which is going to be stored in this particular capacitance Cg1 as well as Cg2, because it is having the direct connection to bit n as well as bit n complement now. So it is going to perform the operation which I have explained you previously. So the charge will be stored either in the form of capacitor Cg1 or in the form of capacitor Cg2 with respect to the VDD component, with respect to this particular VDD supply rail, such that a 1 will turn off and 0 will turn on either of the transistors. So if logical 1 state is having stored in the terms of bit n signal, so that 1 is going to be applied to these two transistors, right? Because it is having a cross coupling connection. So if 1 is applied, means this will be equal to logical means it will be turned off. One is the off condition for a P MOSFET, one is the on condition for N MOSFET. If this is having 0 stored over here, then this particular transistor will get turned on and transistor T2 will get turned off. So when you are going to have such condition, only two of the transistors will be turned on and another two transistors will be turned off. So the current flowing from VDD through an on transistor helps to maintain the bit line state and predetermine the state which will be taken up by the sense flip-flop when sense line is activated. So when you are activating this particular sense line, so at that time the issue can be resolved. So this is regarding the working operation of a 4 transistor type of dynamic memory cell. So one thing is regarding the explanation of this particular circuit in order to perform the read as well as write operation. Another one is this particular circuit which is going to behave like a sense amplifier. So what happens when this becomes equal to a logical 0 state? What happens this becomes equal to a logical 1 state. So when it becomes equal to logical 0 state, I have to explain the behavior of this D flip-flop, like whether bit n is having a logical 1 stored or logical 0 stored. Depending upon that, either of the transistors will get turned on. So this is regarding the working operation of 4 transistors. Let me start with the 6 transistor operation. So 6 transistor static memory cell, once again in order to perform the write as well as the read operation, you have to recharge this particular transistor T7 as well as T8 to a level of logical VDD, that is bit n as well as bit n complement should be precharged to a level of VDD via transistor T7 as well as T8 by taking this precharge complement signal, which will be coincident with respect to the clock signal phi 1, or when this becomes equal to a entire precharge complement becomes equal to a logical 0 state, this particular transistor T8 is turned on and the transistor T7 is turned on, and bit lines, that is in terms of n as well as complement n, it will be precharged to a level of VDD or logical 1 state. So once you are going to precharge it to a value of logical 1 state, then if I am asserting the column select signal as equal to 1, these two transistors will get turned on, and whatever the bit n and bit n complement signal is having the charge, that is in terms of 1 or 0 state, accordingly it will get discharged in the IO bus as well as IO bus complement. So when I am asserting the row select, so this is your row select signal which is coincident with respect to phi 2 once again. When I am asserting this as equal to 1 state, so when this particular row select becomes equal to 1, obviously the transistor T5 is turned on and transistor T6 is also turned on. So both the transistors T5 and T6 will get turned on, and if I am having a particular charge stored over here, if it is 1, then 1 will appear over the output of T5. 1 is applied to an inverter, so 0 will get stored as an output. So CG2 will be having 0 now. Similarly, 1 means CG1 will be having 1 now. So 0 is applied as an input to this particular inverter. So that will yield me the value of 1. Again, charge is stored in these two capacitors of Cg1 as well as Cg2. So that is how the operation of static memory cell is going to be performed in terms of write operation. In terms of read operation, it has to be read from the capacitor via the inverter, then through the transistor, then back to the bus. So bus in the sense the bit lines, bit n as well as bit n complement. So again, there may be the presence of this sense amplifier. What happens when sense amplifier is equal to 0? There is no turning on of this transistor T5. Only T1, T2, T3, T4 will be present, which will be behaving like a flip-flop. Then whatever may be the charge which is stored in this particular, that is values or bit lines, bit n as well as bit n complement, it will be appearing over here depending upon that whether it is equal to logical 0 state or logical 1 state. Any of the or either of the transistors will get turned on, and depending on that it will be performing the operation. So if the sense amplifier is equal to, that is the sense signal value or sense input, which is nothing but the control input what you are going to apply for the transistor T5, if it is equal to, if this particular value of sense is equal to a logical 1 state, or in other terms I can call it as when that particular sense line is activated, the current which is flowing through or flowing from VDD through a on transistor helps to maintain the bit line state and predetermine the state which will be taken up by the flip-flop, that is this particular sense flip-flop, and it is the working operation, what is going to happen or what is going to occur in case of sense signal is equal to a logical 1 state. So this is regarding the working operation of a 4 transistor as well as 6 transistor dynamic memory as well as static memory cell respectively. Hope you understood this concept. Thank you for listening.